Okay, how about for this? Why is it that you guys have studies that look at this apical radiographic changes as an outcome? Okay, so it's a proxy for success. It's correlated with pain.
And by that stage, we change our whole profession. Well, that would be the ideal.
So who are we treating? You have to know that this psychological need to have personal effectiveness, independent of what's perceived by the patient, is shared by all healthcare professions. Okay? I can come up with lots of examples where in my particular specialty, we did the same thing for years, and some people only gave up the outcome measures they cared about when they died. The physician died. Okay? Okay. Means is that if you want unbiased results, so you can estimate the benefit of your treatment, you have got to figure out a way to treat populations that you know you could hold on to. Okay? And this is, I mean, there are many different medical specialties that have run into this exact question, and I can assure you there is no shortcut around this problem. There is no way to massage the data to get rid of the bias associated with informative censoring. Okay? So that's kind of depressing. Okay? But you really ought to think of a group about my whole comment about identifying a captured population if you really want to try to get at this issue. Okay? The point I was trying to make is that in observational studies that patients are often excluded, that you don't know why they're excluded, and it can potentially bias the correlations you see, even before we get to the point that correlation is not causality. So there's this whole set of observational data that you seem to be enamored of in your specialty that I have grave concerns about. And the alternative is to actually try things and the selection of what you try should be informed by the models that you have, or the uncertainty you have in those models, and actually see what happens and do randomized control trials. And I think that if you don't change your mode of doing research to doing randomized trials with good long-term follow-up, that you could invite me back in 5 years, and like our esteemed host, I could just play a tape of my talk this time, and it would still apply. I think you're going to have to do that to break out of this mold. So, for example, it's often been said that you can't change medical science with a single case report. Well, it depends what that case report is. The first case report of a cure of HIV, that changes the way we think about the disease. The one that I used to use as an example was rabies. There had been no patient who had survived after becoming symptomatic with rabies in the absence of partial vaccination. Very specific clinical case, okay? And then there was the first case where a young girl had not been vaccinated but was exposed, developed symptoms and was treated and survived. That completely changed our thinking about that disease. So small data sets, including of teeth, should cause us to rethink what we know about a disease, and our key opinion leaders should be open to thinking of things. Okay, so possible paths forward. Questions to there? And my most important question, when do you want that break? 10:15. Okay, so possible paths forward. There's a tremendous interest and love of observational data. And observational data can take many forms, but essentially the idea is you take advantage of natural variation in your patient population, disease, bacterial counts, whatever it is, and you look at correlations between the thing that's varying naturally and the outcome of interest, which also varies naturally, and you observe those correlations. What you do next is critically important. If all you do is you say, there are correlations, you're fine. And if you say, I know there are correlations, that's fine too. What you have to guard yourself against saying is that if I now change the first thing, the second is going to change. That you don't know at all. So these observational data may take the form of cross-sectional or longitudinal observational studies. I was looking through your literature for randomized trials I could use as an example. I had a very hard time. But I had a very easy time finding people who followed teeth with various degrees of fidelity over time, okay, and then drew correlations and then made them sound like they were causality. If you use this capping agent, you know, you're going to have this rate. If you use that capping agent, I don't even know what I'm saying, then you're going to have a different survival rate, and absolutely nothing about why the practitioner chose one capping agent over another. Like you guys you just flip a coin. Today it's MTA. I don't know what MTA stands for. So you know, today it's MTA, tomorrow it's something else. You don't do that. You choose things, or practitioners at a different stage of training and career have systematic differences in how they make choices. So I have no idea how to interpret that observational literature. Let's talk a little bit about how we might think about how we can move the field forward. And I want to move you away from this preoccupation bordering on obsession with your model, because your model is not going to help you. Okay? I think the model has been taken as far as it's going to get, and so let's get past it. So let's talk about knowledge. It is very easy to confuse what you know you would see on a repeat experiment or an observational study versus what you know in terms of causality. And luckily you have literally one of the world's leading experts on causality here, and he will speak later. But you really need to come to grips with the fact that observational studies don't tell you what will happen when you intervene. And all of your questions clinically are in choice of intervention, including whether to intervene, how to intervene.